Hello everyone, welcome to Prakriya Educations. I am Mallikarjuna. In this module, we shall solve a few problems on types of functions. Look at the first problem. Show that the function f from n to n given by f of x is equal to 2x is 1 but not onto. Before solving this generally, we shall practically analyze the problem first. Now, what is the function defined by? F of x is given by 2x. If I am putting x is equal to 1, according to the definition, f of 1 will be equal to 2 into 1, which will be equal to 2 itself. Therefore, I am mapping 1 to 2. This is our first map. Then if I am putting 2, according to the same definition, 2 into 2, you will map to 4. Then 3 2s are 6. 4 to 8. Now we shall start with the 1 function. According to the definition of 1 function, different elements of the domain should be mapped to different elements of the codomain. And you can check that no two elements in the domain is having the same image, and hence you can conclude that this function f is a 1 function. Now let us analyze for the second one, that is for the onto function. Now, as per the definition of onto, range of the function will be always equal to the codomain of the function, but you can look that in the set of codomain, 1 is an element in the codomain but it is not mapped by any element from the domain. Even 3 is an element and it is not mapped. 5 is an element which is not mapped. 7 again it's not mapped. You can just check out that no odd numbers in the codomain has been mapped, and hence you can conclude that the range is not equal to the codomain. You can conclude that the given function is not an onto function. Now we shall solve the problem generally, that is the first one, the 1 function. Remember the definition, that is for every two elements, let us say x1 and x2, which is chosen from the domain. What is the domain here? N. That is n, which is chosen from the domain. Then if f of x1 is equal to f of x2, we need to prove that x1 is equal to x. This is the mathematical condition for a 1 function. Now we shall start solving this. According to the problem, we shall start with the first assumption. If f of x1 is equal to f of x2, then this implies that what is f of x1? You can check that f of x is 2x. Therefore, f of x1 will be 2x1. That's it. Then f of x2, 2x2. You can cancel 2 and you'll be left with x1 is equal to x2, and hence you have proved from if f of x1 is equal to f of x2, then this implies that x1 is equal to x2. We have proved that, and hence you can conclude therefore f is 1 function. Now we shall prove for the second one, that is for the onto function. Recall the mathematical definition for onto, that is for all y which belongs to n, this is the codomain, then there exists some x which belongs to n, which is x means the element in the domain, such that f of x is equal to y, right? This is the mathematical definition for an onto function. We need to now prove this. Now look in the example or the arrow diagram that we had made. Now you can find many elements which are not mapped. Choose some random element. Okay, if I am choosing the element 5, okay, if I am choosing 5, now you can tell that 5 belongs to natural numbers, that is in the codomain. right? But there does not exist any x which belongs to n from the domain such that f of x is equal to, I've chosen y as 5. F of x is equal to 5. And hence you can now conclude that therefore f is not onto. And hence we have now proved that the given function f from which is defined from n to n is a 1-1 function but not an onto function. Look at the second problem. Show that the function f from r to r given by f of x is equal to 2x is 1-1 and onto. Actually the same problem or the same function as the previous one, but the function is defined from the real number set to the real number set. Now you know that real numbers consist of all positive numbers, negative numbers, fractions and also irrational numbers. In precise you can tell that real numbers is nothing but the union of all the rational numbers as well as the irrational numbers. And hence it is quite difficult to represent all the numbers in the arrow diagram, and hence you can actually take graph of real numbers. That is, if I am having the x-axis and y-axis, considering two real axes, now the function is defined as f of x is equal to 2x. As per this function, if I am going to plot this in the graph, then if I am putting x is equal to 1, then the value of y, f of x is nothing but y. Therefore, y will be equal to 2 into 1, that is 2. If x is 1, y is 2. If x is 2, y is 4, and it goes on, right? Now, if x is equal to minus 1, the value will be minus 2. If x is equal to minus 2, it will be minus 4, and it goes on again. You may have a doubt that again the problem arises that the odd numbers is not being mapped. But look, if I am taking the value of x is equal to, if x is equal to 0.5, what will be the value of y? That is f of 0.5, that will be nothing but 1, right? 2 into 0.5 leads to 1. If I am taking x is equal to 1.5, then what will be the value of y? Y, which is nothing but f of 1.5, leads us to 1.5 into 2, that is 2 into 1.5 gives us 3, right? Now, if x is equal to 2.5, then y will be equal to f of 2.5, which gives us 2 into 2.5, which in turn gives us 5, and it moves on, right? And hence now you may notice that even the odd numbers will be mapped, and hence for some x which is equal to 0.5, you get the value as 1. For x is equal to 1.5, you get the value of 3. For 2.5, you get the value of 5, right? In the same way for the negative numbers also. If you are choosing any real number from the x-axis as the values of x, then 2 into any real number gives back a real number itself. For every element of x, you will be having some element in y, and hence you can conclude that the function is onto. Now, what about 1, 1? Since every element has unique image, you can again conclude that the function is 1, 1 function also, right? And hence the graph will be of the form. This is the graph for the function f of x is equal to 2x. Now we shall solve this problem in the general way. The first one, that is for a 1, 1 function, as per the definition, for every two elements, we shall choose x1 and x2 which belongs to R, that is the domain. Then if f of x1 is equal to f of x2. This implies that what is f of x1? 2x1 is equal to 2x2. 2 gets cancelled and you will be left with x1 is equal to x2. And hence you can now conclude that therefore f is a 1-1 function. Right? Now moving for the second one, that is proving whether it is onto. We have already analyzed in the graph that the function is an onto function. Now according to the definition, you can just write for every element y which belongs to R, this is the codomain, then there exists some element x which belongs to R, this is the domain, such that f of x is equal to y. If we have to prove yes it is onto, you have to prove it in a generalized way, but if you are telling the function is not onto, you have to give a counter example that we had given in the last problem. Now to prove it is onto, we should start in a generalized way. Consider f of x is equal to y. What is f of x function given by? It is 2x is equal to y. We shall now find the value of x in terms of y. Therefore, x will be equal to y by 2. Now, is x is equal to y by 2 an element in the domain? Of course, yes. Because this is of the form a rational number, and a rational number do belongs in the set of real numbers, and hence you can conclude that y by 2 belongs to the real number set. This real number is nothing but the domain set, right? Now verifying this, f of x is equal to f of, what is the value of x? That is y by 2. Now according to the given function, what is the value of f of x? 2x, right? Now just look at this. If f of x is equal to 2x, what is the value of f of y? The value of f of y will be 2y. What is the value of f of y by 2? Which will be nothing but 2 into y by 2. You are clear with this, no? F of y by 2 will be equal to 2 times, in the place of x, you have just replaced it by y by 2. In the same fashion, you can just write this here also. That is 2 into y by 2, which gets cancelled and you will be left with y. And hence f of x is equal to y. And therefore you can now conclude that for every y which belongs to real numbers R, that is in the codomain, then there exists some x which is equal to, what is the x value that we have found? Y by 2, which belongs to again the real number set, which is from the domain, such that f of x is equal to y. We have now proved this, and hence you can conclude that therefore f is onto function. Therefore, f is onto function. Now you can observe that since the function f is both 1-1 and as well as onto, you can even conclude that f is bijective function. Look at the next problem. Check the injectivity and surjectivity of f from n to n defined by f of x is equal to x square. Injectivity is nothing but 1-1 function. Surjectivity is nothing but onto function. I have taken the natural number sets n, and the function is defined from the set of natural numbers to the set of natural numbers, and the function f is defined as f of x is equal to x square. According to the definition, if you are going on connecting or if you are going on mapping, then f of 1 square will be 1 itself, then 2 square 4, 3 square 9, and it goes on, right? Now, is the function a 1-1 function? Of course, yes. Why? Because every element which is there in the domain has unique image in the codomain, and hence you can prove that this function is a 1-1 function. Now, how about onto function? Again, you can look that element 2 is present in natural number set, that is in the codomain, but no element in the domain is been mapped to the element 2, right? And even if you are having an element 3 which is not mapped, 5, 6, 7, 8, all these elements are not mapped, and hence you can conclude that this function is not an onto function. Writing this generally, starting with the first one, that is for the 1-1 function. Now, for every two elements x1, x2, which belongs to what is the domain N, then if f of x1 is equal to f of x2, what is f of x1? F of x is x square, therefore f of x1 is x1 square is equal to x2 square, and x1 will be equal to plus or minus root of x2 square. But now you can observe that you have the sets as the natural number sets, and in the natural numbers there will be no negative numbers, and hence you can neglect the negative side, and hence you will be now left with x1 is equal to plus x2, and therefore you can conclude that f is 1-1 function. Now, for the onto function, according to the definition, you can go on looking here. Choose any number randomly, because I am trying to give a counter example now. Now, if I am choosing an element 2, right? Now, you start writing it as 2 belongs to the set of natural numbers, that is in the codomain, right? 2 is an element in the codomain, but there does not exist any element in the domain N, that is any x, which belongs to the natural numbers N from the domain, such that f of x is equal to 2, right? We have no number in the domain set which is being mapped to an element 2 which is present in the codomain, and hence you can conclude the range is not equal to codomain, and therefore conclude that f is not onto function, right? Since f is 1-1 function and f is not onto function, you can also conclude that f is not bijective function. Check the next problem. Check the injectivity and surjectivity of f from z to z defined by f of x is equal to x square. Again, I have taken the same function f of x is equal to x square, but f is defined from the set of integers to the set of integers itself. F is a function defined from the set z to z by f of x is equal to x square. Now, if I am going on mapping the elements according to the definition, minus 4 in the place of x, f of minus 4, which will be minus 4 the whole square, which leads us to plus 16, right? Minus 4 whole square gives us plus 16. Even if you are squaring up 4, even then you get plus 16. Then minus 3 gives us plus 9. Plus 3 also leads to plus 9. Minus 2, 4. Plus 2, even that as 4. Then minus 1 will give plus 1. Plus 1 gives us plus 1. 0 mapped to 0, and it moves on in the same way. You can look that plus 4 and minus 4 is mapped to a same element. Plus 3 minus 3 is been mapped to the same element, as well plus 2 minus 2, and as well as plus 1 and minus 1. All these two elements are been mapped to the same single element in the codomain, and therefore you can conclude that the function is not a 1-1 function. In the similar pattern, checking for the onto function, you may notice that there are many elements which are not mapped. No negative numbers will be mapped since the function is a square function, and you may also find many elements even in the positive numbers which had not been mapped, and hence you can also conclude that the given function is not onto function also. Now, proving this generally, starting with 1 function. If you are telling that it is not, you may give a counter example to prove this. For 1 I can give the counter example as, yes, plus 2 and minus 2 has been mapped to the same element 4, and you can use that. That is, how can you write f of plus 2, which is equal to plus 2 the whole square, according to the definition, gives us plus 4. Then f of minus 2, which is equal to minus 2 the whole square, which also gives us plus 4. Therefore, f of plus 2 and f of minus 2 is equal to the same image 4, and hence you can conclude different elements of domain has same image in the codomain, right? And therefore this is the contrary for the definition of 1 function, and hence you can conclude f is not 1 or f is not an injective function. F is not injective function. Fine. Now proving for the second one, that is for the onto. Again, you can give a counter example in the same way. That is, you choose some random element in the codomain which is not been mapped. I shall now choose minus 3. Okay. Minus 3 belongs to the codomain Z, but there does not exist any element X which belongs to Z, that is the domain set, such that f of x is equal to minus 3, and hence you can now conclude that f is not onto function or f is not surjective function. Hence, now we have proved that f is not injective function and f is not a surjective function, and this leads to conclusion that f is not bijective function. If the function f is defined from the real number set R to the real number set R by the same definition, f of x is equal to x square, even then you can prove that f is neither 1 nor onto. You may use the same counter examples which we have done here for the function f from R to R defined by f of x is equal to x square to prove that it is not 1 nor onto. That's all for the day. In the next module, we shall again continue solving more problems on the types of functions. Until then, enjoy doing math. Hope you enjoyed the video. Please don't forget to like, share and subscribe. Thank you.